The National Electrical Code, or NEC, serves as a foundational set of safety requirements governing electrical installations. It's meticulously crafted by the National Fire Protection Association, or NFPA, and subsequently adopted by local authorities to ensure consistent safety standards. It is important to understand that the NEC typically does not contain specific stipulations regarding the installation of fire-rated plywood or painted plywood within communication closets. This is primarily because the NEC core focus is electrical safety, whereas the installation of fire-rated plywood is considered predominantly a fire protection matter. Organizations like BICSI, Building Industry Consulting Service International, and I/TIRE, Electronic Industries Association/Telecommunications Industry Association, are instrumental in developing standards tailored for the telecommunications industry. Although these standards aren't legally binding mandates, they are frequently used by businesses and organizations as guiding principles for designing and installing telecommunications systems. The inclusion of requirements for fire-rated plywood in communication closets within BICSI and EIA/TIA standards stems from a recognition of its importance as a fire protection measure. There are several underlying reasons explaining why the NEC doesn't incorporate a specific requirement for fire-rated plywood in communication closets. One significant factor is that the NEC is designed to establish a minimum safety threshold. This framework allows local authorities the flexibility to adopt more rigorous requirements, but prevents them from implementing less stringent ones. Introducing a specific requirement for fire-rated plywood in NEC would inadvertently limit the ability of local authorities to enforce more robust measures, such as requiring the installation of fire-rated drywall. Another key reason is that the NEC is not intended as a comprehensive design guide. While it establishes minimum safety standards, it refrains from providing detailed guidance on designing electrical systems. Typically, the responsibility of designing electrical systems rests with qualified electrical engineers who possess the expertise to consider various factors beyond the scope of the NEC. Furthermore, the NEC undergoes updates on a 3-year cycle. This cyclical update process means that it may not always be able to promptly incorporate the latest technological advancements. The telecommunications industry is characterized by constant evolution, with new technologies emerging regularly. Consequently, the NEC may sometimes lag in integrating the most current requirements for installing telecommunications systems. The absence of a specific requirement for fire-rated plywood in communication closets within the NEC doesn't negate its importance. On the contrary, installing fire-rated plywood is strongly recommended. Fire-rated plywood serves as a crucial safeguard, protecting electrical equipment within the closet from potential fire damage. When tasked with installing electrical equipment in a communication closet, prioritizing fire protection is paramount. This involves ensuring the installation of fire-rated plywood on the walls and ceiling of the closet. Furthermore, the electrical equipment must be properly grounded, and adequate ventilation should be maintained within the closet. By diligently implementing these precautions, the risk of fire damage to electrical equipment is significantly reduced, ensuring the safety of personnel and customers. Now let's delve into more detail about why each of these items is important. Firstly, let's talk about the NEC role as a minimum safety standard. The NEC, as we've established, is designed to set a baseline for electrical safety. Its primary goal is to prevent electrical hazards such as shocks, fires, and explosions. It achieves this by specifying requirements for wiring, overcurrent protection, grounding, and equipment installation. Because it focuses on minimums, it doesn't delve into every possible safety precaution that could be taken. Think of it like building codes for a house. They specify the minimum requirements for structural integrity, fire safety, and plumbing, but they don't dictate the type of flooring you must use or the color you must paint the walls. Those are design choices that go beyond basic safety. The same principle applies to the NEC. It ensures that electrical installations are safe, but it doesn't prescribe every detail of the installation, especially when it comes to areas that fall outside of pure electrical safety, such as fire protection of non-electrical components. Secondly, we consider the flexibility for local authorities. The NEC is adopted by local jurisdictions such as cities, counties, and states. These jurisdictions have the authority to amend the NEC to make it more stringent based on local needs and conditions. For example, a city located in an area prone to wildfires might adopt stricter requirements for fire-resistant building materials than what is specified in the NEC. This local control is essential because conditions and priorities vary across different regions. If the NEC were to mandate fire-rated plywood in communication closets, it would remove the flexibility of local authorities to implement more comprehensive fire protection measures, such as requiring fire-rated drywall or sprinkler systems. The NEC is not intended as a design guide. The NEC provides rules for safe electrical installations, but it doesn't tell you how to design an electrical system. Electrical system design involves complex calculations, load analysis, equipment selection, and coordination with other building systems. These tasks require the expertise of a qualified electrical engineer. An electrical engineer considers various factors such as the building's occupancy, the types of equipment being used, and the local environmental conditions to design an electrical system that meets the specific needs of the building. The NEC provides the safety framework within which the electrical engineer must work. However, it doesn't replace the need for engineering expertise. Including detailed design requirements in the NEC would blur the line between code requirements and engineering design, potentially leading to confusion and inconsistencies. Let's discuss the NEC update cycle and technological advancements. The NEC is updated every 3 years to keep pace with changes in technology and industry practices. This update cycle involves a rigorous process of public input, technical review, and consensus building. While the NEC aims to incorporate the latest advancements, it's impossible to cover every emerging technology in each edition. The telecommunications industry, in particular, is rapidly evolving. New cabling standards, networking equipment, and communication protocols are constantly being developed. Because of this rapid pace of change, the NEC may not always include the most current requirements for telecommunications installations. Instead, industry-specific standards, such as those developed by BICSI and EIA/TIA, often fill this gap by providing more detailed guidance on telecommunications installations. The importance of fire-rated plywood cannot be overstated. Despite not being explicitly mandated by the NEC, the use of fire-rated plywood in communication closets is highly recommended for several reasons. Fire-rated plywood is treated with a fire-retardant chemical that slows down its combustion and reduces the spread of flames. This can buy valuable time for occupants to evacuate a building and for firefighters to respond to a fire. In a communication closet, which often contains sensitive electronic equipment, fire-rated plywood can help protect this equipment from heat and flame damage. This can prevent costly downtime and data loss. Fire-rated plywood is an important component of a comprehensive fire protection strategy. It should be used in conjunction with other fire safety measures, such as smoke detectors, fire extinguishers, and sprinkler systems. If you're responsible for installing electrical equipment in a communication closet, it's essential to take fire protection seriously. This includes installing fire-rated plywood on the walls and ceiling of the closet. This ensures that the electrical equipment is properly grounded. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and de-energizing the circuit. This prevents electrical shocks and reduces the risk of fire. Make sure the closet is properly ventilated. Ventilation helps to dissipate heat generated by electrical equipment, preventing overheating and potential fire hazards. Now, let's get into more details about some of the best practices that you can use when installing electrical equipment. Firstly, select the correct type of fire-rated plywood. Fire-rated plywood is available in different grades, depending on its fire resistance rating. Select a grade that is appropriate for the specific application. Secondly, install the plywood correctly. Make sure that the plywood is properly fastened to the walls and ceiling of the closet. Use screws or nails that are long enough to penetrate the framing members. Thirdly, seal all gaps and cracks. Seal all gaps and cracks around the plywood with a fire-resistant sealant. This will prevent smoke and flames from spreading through the gaps. Fourthly, inspect the plywood regularly. Inspect the plywood regularly for signs of damage. Replace any damaged plywood immediately. It is important to consider fire stopping as part of the process. Fire stopping is the process of sealing openings and penetrations in walls and floors to prevent the spread of fire and smoke. When installing electrical cables or conduits through fire-rated walls or floors, it's essential to use fire-stop materials to seal the openings around the penetrations. This will maintain the fire resistance rating of the wall or floor and prevent fire from spreading to other areas of the building. The NEC addresses fire stopping requirements in section 300.21, which states that installations through fire-resistant rated walls, partitions, floors, or ceilings shall be so made that the fire resistance rating is maintained. This means that any openings created for electrical installations must be properly sealed with fire-stop materials that are listed for the specific application. There are various types of fire-stop materials available, including sealants, putties, and pillows. Choose a fire-stop material that is appropriate for the type of penetration and the size of the opening. Follow the manufacturer's instructions carefully when installing fire-stop materials. The NEC also addresses the grounding of electrical equipment in Chapter 250. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current to flow back to the source. This helps to prevent electrical shocks and reduces the risk of fire. All electrical equipment that is likely to become energized must be grounded. This includes metal enclosures, raceways, and equipment frames. Grounding is achieved by connecting a grounding conductor from the equipment to a grounding electrode, such as a ground rod or a metal water pipe. The size of the grounding conductor must be appropriate for the size of the circuit. The NEC provides tables that specify the minimum size of grounding conductors based on the size of the overcurrent protection device. In addition to equipment grounding, the NEC also requires the grounding of electrical systems. This is typically achieved by grounding the neutral conductor of the system. System grounding helps to stabilize the voltage of the system and provides a path for fault current to flow back to the source. Proper ventilation is crucial for preventing overheating and potential fire hazards in communication closets. Electrical equipment generates heat as it operates. If this heat is not dissipated, it can cause the equipment to overheat, leading to malfunctions, reduced lifespan, and even fire. Ventilation helps to remove heat from the closet and maintain a safe operating temperature. There are several ways to provide ventilation in a communication closet. One option is to install a fan that draws air from outside the closet and exhausts it to the outside. Another option is to install louvers or vents in the door or walls of the closet to allow for natural convection. The amount of ventilation required depends on the amount of heat generated by the equipment in the closet. A qualified electrical engineer can perform a heat load calculation to determine the appropriate ventilation requirements. The NEC does not provide specific requirements for ventilation in communication closets. However, it does require that electrical equipment be installed in accordance with its listing and labeling. The listing and labeling of equipment may specify ventilation requirements. In addition to the NEC, other codes and standards may provide guidance on ventilation requirements for communication closets. These include the International Mechanical Code and the American Society of Heating, Refrigerating, and Air Conditioning Engineers, or ASHRAE, standards. Remember that the requirements for fire-rated plywood and fire stopping may vary depending on local codes and regulations. It's essential to consult with local building officials and fire marshals to ensure compliance with all applicable requirements. These officials can provide guidance on the specific requirements in your area and help you ensure that your electrical installations are safe and code compliant. Let's talk about the different types of cables that can be used in a communication closet and the types of cable that are fire rated. Communication closets often house a variety of cables, including data cables, voice cables, and power cables. Data cables, such as Category 5E, Category 6, and Category 6A cables, are used to transmit data between computers and other network devices. Voice cables are used to transmit voice signals between telephones and telephone systems. Power cables are used to supply power to electrical equipment in the closet. Some cables are fire-rated, meaning that they are designed to resist the spread of fire. Fire-rated cables are typically used in plenum spaces, which are spaces used for air circulation in buildings. Plenum spaces are often located above ceilings or below floors. The NEC requires that cables installed in plenum spaces be fire-rated. Fire-rated cables are classified according to their fire resistance rating. The most common fire resistance ratings are CMP, CMR, and CM. CMP cables are the most fire resistant and are suitable for use in plenum spaces. CMR cables are less fire resistant than CMP cables but are still suitable for use in some plenum spaces. CM cables are the least fire resistant and are not suitable for use in plenum spaces. The type of cable that you should use in a communication closet depends on the specific application and the local codes and regulations. Consult with a qualified electrical engineer or building official to determine the appropriate type of cable for your application. When installing cables in a communication closet, it's important to follow good installation practices. Firstly, support cables properly. Support cables using cable trays, J-hooks, or other approved supports. This will prevent the cables from sagging or becoming damaged. Secondly, avoid sharp bends. Avoid bending cables sharply, as this can damage the conductors inside the cable. Thirdly, maintain proper separation. Maintain proper separation between power cables and data cables. This will prevent electrical interference from affecting the data signals. Fourthly, label cables clearly. Label all cables clearly so that they can be easily identified. Fifthly, document cable runs. Document all cable runs so that you can easily locate and troubleshoot cables in the future. Let's discuss surge protection for your equipment and how to maintain the closet for maximum safety. Surge protection is an important consideration for electrical equipment and communication closets. Surges are sudden increases in voltage that can damage or destroy electronic equipment. Surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protection devices, or SPDs, are designed to protect electrical equipment from surges by diverting the surge current to ground. SPD are available in a variety of types and sizes. The type of SPD that you should use depends on the specific application and the level of surge protection required. SPD should be installed at the service entrance of the building and at each piece of equipment that needs surge protection. The NEC addresses surge protection requirements in section 230.67. This section requires that SPD be installed in dwelling units and in certain other types of buildings. Even if the NEC doesn't require a SPD in your specific application, it's still a good idea to install them to protect your electrical equipment from surges. Another important consideration for electrical equipment in communication closets is maintenance. Regular maintenance can help to prevent electrical problems and ensure that the equipment is operating safely and efficiently. Maintenance tasks should include inspecting equipment regularly for signs of damage, cleaning equipment to remove dust and dirt, tightening connections to prevent loose connections, testing equipment to ensure that it is operating properly, and replacing equipment that is worn or damaged. A qualified electrician should perform maintenance on electrical equipment. The frequency of maintenance depends on the type of equipment and the operating environment. However, it's generally recommended to perform maintenance at least once a year. By following these guidelines, you can help to ensure the safety and reliability of electrical equipment in communication closets. Finally, consider having an emergency plan. In the event of a fire or other emergency, it's important to have a plan in place to protect your employees and your equipment. The emergency plan should include procedures for evacuating the building, shutting down electrical equipment, and contacting emergency services. The emergency plan should be practiced regularly so that everyone knows what to do in an emergency. By taking these precautions, you can help to protect your electrical equipment from fire damage and ensure the safety of your employees and customers. Remember, even though the NEC doesn't specifically call out fire-rated plywood in communication closets, it's a very good idea to include it to keep your equipment and people safe.